Everyone, so today will be our last section before we take our exam next week. Now, just a reminder that you will take your exam on the day you have me. There will also be a really small lesson for the students that are remote and so forth. So just keep a lookout. If you have any questions, please email me. So today we're going to hopefully be able to understand how to write a quadratic from standard form to vertex form and vice versa. And to tell you the truth, the way to change from a standard form of an equation, a quadratic equation, to a vertex form is 100% review, and the other way around as well. The three prior skills that you are going to need are how to complete the square. So that is what I'm hoping to cover in problems 1 and 2, and also how to FOIL out a binomial. So if you know how to do these three things, today is going to be a breeze going from standard to vertex form and vice versa. And if you don't, it'll give you an extra chance to practice. So let's remind ourselves what it means to complete the square of a quadratic. So if you remember, completing the square is really forcing a quadratic to be a perfect square trinomial. That is what you're doing when completing the square, and there's a specific order that you have to do that. Now notice here that we do not have a perfect square trinomial. X squared is a perfect square, but notice that 20 is not a perfect square. So you need to think of, okay, what number does 20 need to be? Now remember, in order to complete the square, you only need to worry about the first two terms, your quadratic term and your linear term. So let's move this 20 to the other side just to get it out of the way. We end up with x squared minus 10x is equal to a negative 20. Now let me write that 10 a little nicer so that way we know we're not confused of what that number is. Now, again, we need to think of that number that makes the left side a perfect square trinomial. So remember that in order to do that, that is what is called completing the square. Your leading coefficient from your x squared needs to be a 1. In this situation, it already is. In order to figure out what number goes there, we take half of the middle. So let's take that negative 10 and divide it by 2. We end up with a negative 5. And then we square it. Now, when we square it, negative 5 squared is a positive 25. So I'm going to add 25 to the left side to make the left side a perfect square trinomial. I'm also going to do it to the right side. Now, if you're a little stuck on why in the world we have to take half of it and square it, you'll have to go back to completing the square. I'm assuming now that you already know how to do that. This is kind of just focusing on the practice. So notice that this is a perfect square trinomial, so you know it's going to factor to a binomial squared. What times itself equals x squared? What times itself equals 25? Keep in mind that your signs in the middle are going to match up, so that means that that perfect square trinomial factors to x minus 5 squared. Now, completing the other side, notice the negative 20 plus 25 is just a positive 5. But the moral of the story here that I'm trying to get you from this entry test is understand what is going on here to make it look like that. So that is what completing the square is. That is what I want you guys to be able to do. And if you do, awesome. And if not, you'll get some extra practice. So let's go ahead and do another one of these, but one that provides a little more pre-work. So you can see here that we do not have a perfect square trinomial. Yes, 4x squared is a perfect square, but 7 is not. So let's make this a perfect square trinomial. Let's minus 7 on both sides. You end up with 4x squared plus 8x is equal to a negative 7. Now remember, your leading coefficient when you complete the square has to be 1. Notice that you have a 4 there, so I'm going to divide by 4. So that way I end up with x squared plus 2x is equal to a negative 7 over 4. And remind yourself again that in order to, what I'm doing here is just getting my equation prepared in order to complete the square. Now that my leading coefficient is 1, I'm only worried about the first two terms. I could take half of my middle term, so half of 2 is 1. I could take my middle term and divide by 2, because I'm taking half of it. 2 divided by 2 is 1, and then I'm going to square whatever my result is to end up with that number that makes this a perfect square trinomial, which in this situation is 1. Remember, when you add something to one side, you have to add it to the other. Now you have a perfect square trinomial here. 1 multiplies itself to x squared. X 1 multiplies itself to 1. That'd be a 1. Don't forget that the positives or the middle signs are always going to match. Now, on the right side, we have negative 7 fourths plus 1. I don't want you to worry about adding this fraction because, again, the concept or the skill that I want you guys to be familiar with, or at least have a basic foundation, is all this stuff. Is making sure that you know how to complete the square for today's problems. All right, so one more skill you'll have to know. One is completing the square like 1 and 2, and the other one is foiling like number 3. Now, what I want you guys to do here is simplify this as much as possible, aka I want you to foil. Notice we have 2 times x minus 4 squared. What I want to do here is simplify x minus 4 squared, and then I want to multiply it by 2. So what I'm going to start with first here is the binomial. I want to simplify this out, aka FOIL. So I have x minus 4 times x minus 4. Remember that when you are multiplying two binomials, you have to multiply each term with each term. X times x is x squared. X times a negative 4 is negative 4x. Negative 4 times x is a negative 4x. And a negative times a negative 4 is a positive 16. Now, combining like terms, keep in mind that negative 4 minus 4 is a negative 8x. Forgot my square then. Don't forget your plus 16. Now, just a reminder that we foiled out x minus 4 squared. Now, this 2 is just hanging around, still multiplying everything. So don't forget that 2 out in front. We did the green, which was the majority of when the mistakes happen if they do, which is foiling out that binomial. But now that we did it correctly, all we have to do is distribute our 2. So we end up with 2x squared minus 16x plus 32. And that is how you foil out. If you 100% understood what I just did, today's going to be a breeze. And if you don't, again, you're going to get a little more practice. So let's go ahead and start getting to converting between standard and vertex form of quadratics. Now you'll notice over here while this takes a picture that the left side is already in standard form and the right side is in vertex. Now it is actually quite easy to go from standard form to vertex form because the process that you need to do is complete the square. If you could complete the square, you know how to go from standard to vertex. Now, let's say I give you something in vertex and want you to go back to standard. Well, that process is just to FOIL and simplify. So you can see why we did the entry task is to give us that foundation, that mindset of, okay, what is completing the square? How do I do it? And you can see why we did FOIL, because again, it gets you in that mindset. Of course, they're going to look a little bit differently. It's not going to be exactly like the entry task, but for the most part, the overall concept is there. You just need to train your mind to be like, okay, I'm in standard form, I need to complete the square to get to vertex. If I'm in vertex and want to get to standard, I'm going to FOIL and simplify as much as possible. So let's go ahead and do one at a time, and let's concentrate on going from standard to vertex. So notice that all these problems are already in standard form, and it's your job to change them to vertex form. So remember, the form that we do that is by completing the square. So notice that you have equations, so you can't exactly do the same process. It's a little different. And let me show you how. So notice that the right side is not a perfect square trinomial. 5 is not even a perfect square. So that means what I'm going to do is concentrate on my first 2 terms. Now, it doesn't make sense just to add 5 to the other side because you have your y. This is an equation. So what I like to do is just rewrite it, but this time leave an open space for that magical number. So when you actually complete the square. Now, in order to complete the square, your leading coefficient has to be a 1, which it is in this situation. Now, in order to complete the square, you take half of the middle term. So in this situation, it's going to be a negative 2. Let's divide it by 2, which gives me a negative 1. And let's square it. Negative 1 squared is a positive 1. So that is my magical number that I need in order to make this a perfect square trinomial. So here I go. I'm going to add 1. Now, this is where students get a little confused at because notice I added 1. This equation is not balanced. I technically added something to the right side that I didn't add to the left side. So in order to fix it, what I'm going to do is, okay, if I added 1 and subtract 1, technically I haven't done anything, how would I say, unbalancing my equation. I added 1, subtract 1. That equals 0, so technically I added 0. Now, if I know it's going to equal 0, why did I do that for? Again, because you need that positive 1 in order to make a perfect square trinomial, which is that middle piece that I just underlined in blue. If you were to factor that, you know that's a perfect square trinomial. What times itself equals x squared? X. What times itself equals 1? 1. Make sure that your inside sides match up. Don't forget that, again, this is a binomial square. And then that was our whole goal. at the end, this is just collateral damage, so to speak. It's just what happens on the outside of my main goal of getting that binomial square. -1 minus 5 is a -6. So you can see here that we actually converted this to vertex form just by completing the square. Again, we had to do a little bit of different things, but for the most part, it's exactly the same. You're completing the square with the same requirements. Now that you have it in vertex form, you can graph in vertex form if you want. But again, my goal here is to make sure that you're comfortable changing between them. So let's go ahead and continue. So number 2 is just another example. Notice that this doesn't even have a third term. So I need to figure out what is going to make this a perfect square trinomial. Now, let's go ahead. My leading coefficient is already 1 in front of the x squared. Let's take half of the middle. Excuse me, by dividing by 2, which gives me a +2, and then let's square that 2 to end up with a +4. So that is my magical number. I'm going to add 4 because that gives me a perfect square trinomial. Now again, you just can't add 4 to one side. Typically what you do is add 4 to the other, but keep in mind, in order to keep things balanced, you can also just do the opposite on the same side. Now, why did we do that? Again, because we need the +4. The -4 is just that tag-along friend that comes along, so to speak. So let's factor this. This is, again, a perfect square trinomial, so it's going to factor binomial squared. What times itself equals x squared? X. What times itself equals 4? 2. Keep in mind that the inside signs aren't going to match. Our -4 has nothing to add with anything else, and that means we have converted to vertex form. All right, so additional examples, that way you can kind of see this and see something different. Because notice number 3 is a little more challenging, because notice you don't have a perfect square trinomial, so you need to complete the square in order to make this a perfect square trinomial to get it to vertex form. Now you only need to worry about the first 2 terms, so you need to worry about 6x squared and a +12x, and then I'm going to leave that 5 somewhere out here just because I know I need to figure out what number goes here to make this a perfect square trinomial. Now, what happens if my leading coefficient isn't equal to 1? It's equal to 6. Well, what is something I could do with equations that would make this a 1? And the answer is that you would just factor. Concentrate on your first 2 terms and factor out whatever that leading coefficient is, because if you factor, specifically the greatest common factor, notice that you're going to have that 6 come out of the parentheses, which is a +6. You're going to be left with x squared. And then finishing this off, 6 times what is 12x? That'd be a +2x. So notice that I really didn't do anything different. All I did there was just factor out a greatest common factor. I rewrote it for the benefit of whatever purposes I'm doing, is to complete the square. So let's go ahead and do that. You can see if you were to multiply this back, you'd end up with 6x squared and then a +12x. So nothing's changed. You just changed the look of it. Because again, you need a leading coefficient of 1. Now you can take half of the middle. So 2 divided by 2 is a +1. Don't forget to square it. In this situation, you're going to end up with the same number, which is a +1. Now this is where things get a little tricky. Because remember, you just can't add 1. You also have to subtract 1. Now this is a little bit, what I like to say, undercover, because technically, yes, you did subtract 1. But notice what's in front of these parentheses. If you were to distribute back, what did you technically add? Well, 6 times a -1 is a -6. So before you take it out of this parentheses, you have to multiply by the leading coefficient, because that -1 isn't a -1. You're technically multiplying by 6. So a -6 comes out. That is pretty much that 1. But you gotta know why it's -6, and that's challenging because, again, this is the first time you've done this math, so you'll notice that 6 is out there, and I can hopefully explain further in the second problem as well. So here I go, my 6 stays out in front. I know this factors out to a binomial squared. What times self equals x squared? X will multiply itself to 1. Your signs are going to match. -6 plus 5 is a -1. Now, keep in mind that if you were kind of confused of why it came out to be a -6, pay attention for that step in the second problem, so that way, hopefully, it makes a little more sense. The shock is over, at least in the first problem, and you can get it the second time. All right, so let's go ahead and do that. So if I look at this problem, it's not a perfect square trinomial. So in order to get it to vertex, I have to factor, or I have to complete the square. It changes to a perfect square trinomial. Now, concentrating on those first 2 terms, I can clearly see that my leading coefficient is not 1. So what I'm going to do is I'm going to factor out the leading coefficient of 5, because if you factor out the greatest common factor, which is technically in the situation that number, I'm going to end up with a 1 as my leading coefficient. So let me go ahead and do that. I take out that 5, I'll be left with an x squared minus 2x. And then my plus 1 is just hanging out. Forgot to leave a little space, so I'm going to go ahead and do that. Now that you have your leading coefficient of 1, which is why I factored out this 5, I could complete the square. That means I'm going to take half of the middle, which in this situation is negative 2. I end up with a negative 1, and then I square it, which gives me that positive 1. It gives me that number that makes it a positive 1. Now I know what you're thinking, why can't I not just subtract 1 on the outside? Because again, notice that when you added this 1, yes, you added it within the parentheses, but you didn't take into account this 5. So what you technically added was not 1, but 5. So if you're going to do the opposite, you just can't subtract 1. You have to subtract a 5 outside of your parentheses. So that is why I have this minus 5. Again, it's going to take some time to get used to. Just make sure you're kind of trying to think through it to see why it makes sense. So let's go ahead and factor this. My 5 stays the same. This is a perfect square trinomial, so it's going to factor to a binomial squared. X times x is x squared. 1 times 1 is 1. Keep in mind that your signs are going to match. Negative 5 plus 1, the outside stuff that we really don't care about in terms of completing the square, but is important for the end result. Negative 5 plus 1 is a negative 4, so that is your vertex form. So these, again, are easier problems because you don't have to worry about that factoring in that leading coefficient of 1. These are harder problems. They both can show up on your test, but now you know how to do these problems. And there's one more set of problems that we have to do. So that way you have all the information for your test. The good thing that this is a little bit easier because we're going from vertex to standard form. Now notice when you have standard form and we write it to remind ourselves, you don't have any parentheses. So your first goal whenever you have vertex form and you're trying to go to standard form is to get rid of those parentheses. So FOIL those binomials. The way I like to do it is always write my two binomials as two separate groups, so that way I can multiply them one step at a time. Now don't forget the outside stuff. And I'm going to change color so that way I can make sure I don't forget it and it kind of stands out. So let me go ahead and FOIL this out. X times x is x squared. X times 1 is a positive x. 1 times x is a positive x. And 1 times 1 is a positive 1. Now combining like terms, I'm going to end up with x squared plus 2x plus 1. Don't forget everything else is going around. Keep in mind that you're doing a problem within a problem. This minus 3 is still hanging out. You still have y equals out in front. And now you're ready to combine like terms. Now notice the positive 1 minus 1 you can combine. So you end up with x squared plus 2x minus 2 because a positive 1 minus 3 is a negative 2. So now you have a standard form. Notice that you know what your A is, your B is, your C is, and you can move on. All right, let's go ahead and do number 2. We have a little more things going on, but remember your rules of PEMDAS. If you're doing math here, what would you do first? There's no work inside the parentheses, so then you would do your exponents. So you want to do your exponents first. I like to kind of just take some time and write them out and then do the hardest part first and then bring out my outside information. So let me go ahead and do that. X plus 4 squared is just x plus 4 times x plus 4. Now I have to FOIL this out. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is positive 16. Combining like terms in the middle, you end up with a positive 8x plus 16. Now let's remind ourselves what was going around on the original problem. We had y is equal to negative 3 times the brown plus 1. So you're still going to multiply all the brown by negative 3. Don't forget to add 1 at the end. So hopefully you can see there that how it filled in that we just did concentrate on the binomials and now we're ready to bring in everything else. So now that we did exponents, remember to do multiplication. When you distribute, you are multiplying. So that is what is next. You end up with a negative 3x minus 24x. 3 times 16 is 16, 32, 48, negative 48. Don't forget your plus 1. And now you can see there's only one less thing to combine. So you end up with 3x squared minus 24x minus 47. And you have now figured out everything, or you have all the information for your guys' exam that's going to happen next week.